Welcome to this explainer. Today, we're journeying back in time to explore the awe-inspiring Jantar Mantar observatories. We're going to see exactly how one visionary leader solved a massive 18th century problem, creating an architectural and scientific marvel that fundamentally changed how we understand our place in the universe.
So, let's kick things off with a huge question that faced ancient astronomers who were trying to decode the night sky. Imagine trying to precisely measure the movement of planets, the exact moment of an eclipse, or the changing of the seasons. But here's the catch. You don't have a single telescope or digital computer at your disposal. How do you achieve absolute precision with nothing but the naked eye?
Well, the answer involves structures of truly immense scale. 27 meters. That's the height of an incredible stone sundial built in India to solve this exact problem. By scaling up their instruments to massive proportions, astronomers found they could measure the shadow of the sun and the alignment of the stars with mind-boggling precision. But why go to such extreme lengths in the first place?
Section 1. A Map of the Heavens, the 18th Century Crisis.
To understand why these giants were built, we really have to look at the global crisis of inaccurate planetary predictions during the 1700s. The world was changing rapidly, and the old ways of tracking time, they were failing. Inaccurate maps of the heavens were causing absolute chaos for Mughal emperors and Hindu priests alike. And this wasn't just some abstract scientific issue, it threatened everyday life. Literally everything from crop planting and agricultural planning to the exact timing of sacred festivals relied on accurate celestial calendars. There were glaring discrepancies between the traditional Hindu almanacs and the actual positions of the planets. The Mughal Empire desperately needed reliable imperial calendars to govern effectively. The sky was the ultimate clock, and, well, the clock was broken.
Section 2. The Scholar King's Vision, Maharaja Sawai Jai Singh II.
Enter our visionary, a brilliant scholar king who took it completely upon himself to fix the calendar. Born in 1688 and ascending to the throne of Amber at just 11 years old, Jai Singh II was definitely not your average ruler. He was a polyglot, fluent in Sanskrit, Persian, and Arabic, and he was deeply passionate about mathematics and astronomy. He became a veritable melting pot of global science. He didn't just look in his own backyard. He synthesized Greek, Islamic, and Hindu astronomical texts. He actually sent scholars across the globe to gather the most advanced astronomical knowledge available. He integrated ancient Indian methodologies with high-precision star catalogs from Islamic scholars. He even incorporated European insights, having texts like Ptolemy's Almagest translated directly into Sanskrit. He was building a unified, cross-cultural system of the heavens.
Section 3. Replacing brass with stone, the radical solution.
Despite all this gathered knowledge, Jai Singh quickly realized a major problem. Traditional, handheld tools just weren't going to cut it for the extreme level of precision he desired. The existing technology was literally holding the mathematics back. So, he made this radical technological leap. He completely abandoned fragile brass instruments in favor of massive, permanent stone architecture. Small brass astrolabes were portable, sure, but they were fragile. Their limited scale meant you could only get so accurate, and the metal was prone to wear and tear over time, which completely threw off calculations. Monumental stone yantras, or instruments, solved all of this. Built from local stone, marble, and masonry, they were highly stable. By making them massive, he extended the gradations on the measuring scales, allowing for exceptional naked-eye precision that just couldn't be achieved with handheld metal tools.
Section 4. A Tale of 5 Cities, the Observatories.
To map the entire sky accurately, Jai Singh didn't just build one observatory. No, he built an entire network of them across northern India to gather coordinated data. Throughout the 1720s and 30s, he created an unprecedented grid of celestial data collection. He starts in 1724 with the first observatory in Delhi. A year later, he expands to Ujjain and Mathura. By 1727, he's constructing the massive complex in his newly founded capital of Jaipur, and finally, in 1737, he initiates the site in Varanasi. By cross-referencing observations from all these different latitudes, his team of astronomers could eliminate localized errors and create a remarkably accurate standardized map of the cosmos.
Let's break down the three most prominent surviving sites and the unique roles they played in Jai Singh's astronomical empire. First, you have Jaipur. This is the crown jewel, the largest complex featuring 19 main instruments, and it's now recognized as a UNESCO World Heritage Site. Then there's Delhi, the first site, which served as a highly strategic political gift to the Mughal Emperor Muhammad Shah to show loyalty and collaboration. And Ujjain, positioned near the Shipra River, which was incredibly significant because it served as the prime meridian in ancient Indian traditions, essentially the geographical zero point for all their celestial calculations.
Right at the heart of Jaipur sits the Vrihat Samrat Yantra, and it is an absolute marvel of medieval engineering and naked-eye observation. Just picture a sundial constructed out of pink sandstone and marble that towers over the landscape at 27 meters tall, functioning as a supreme equinoctial timekeeper.
2 seconds. Thanks to its immense size and finely etched marble scales, this specific structure can calculate local time to an astonishing accuracy of just 2 seconds. Let that sink in for a second. Without electricity, without digital gears, just utilizing the rotation of the Earth and the shadow of the Sun against a perfectly calibrated stone ramp pointing directly at the North Pole. It's brilliant.
And this illustrates not just timekeeping, but complex planetary tracking. To understand the mechanics of how these actually functioned, let's look at the Digamsa Yantra in Ujjain and the steps used to track the exact compass direction, or azimuth, of celestial bodies. It's such an ingenious design. You have a central pillar surrounded by concentric circular walls. Step 1, you align a weighted string from the pillar. Step 2, you track the celestial object across the walls. And step 3, you read the exact angle from incredibly fine markings etched into the stone, markings as fine as 1/10 of a degree.
Ujjain was particularly vital for these measurements because it served as the 0 point of longitude for celestial calculations in ancient texts. It is geographically situated right on the Tropic of Cancer, earning it the awesome nickname, the Greenwich of India. Placing an observatory here perfectly bridged ancient geographical traditions with cutting-edge 18th century observational data.
Section 5. An enduring astronomical legacy.
Ultimately, Jai Singh's monumental quest was a resounding success. It culminated in highly accurate astronomical tables that updated planetary positions and, quite literally, set the clocks for an empire. Today, these sites stand not just as magnificent ruins, but as a permanent testament to human ingenuity and the seamless fusion of art, architecture, and science. The impact was massive. His team produced revised astronomical tables that directly corrected errors in earlier records. Amazingly, some of these instruments in Jaipur were actively used for weather forecasting and calendar updates well into the mid-20th century. It's an enduring symbol of pre-modern scientific heritage, which is exactly why the Jaipur complex was rightfully declared a UNESCO World Heritage Site in 2010.
In fact, the very name Jantar Mantar translates poetically to instruments for measuring the harmony of the heavens. The word jantar is a colloquial corruption of the Sanskrit word yantra, meaning instrument, and mantar comes from mantrana, meaning to calculate or consult. Together, they perfectly capture the beautiful, calculating spirit of these architectural wonders.
Which brings us to today. As we rely so blindly on the digital clocks and GPS devices in our pockets, I want to leave you with this final thought to ponder about our own connection to the cosmos. Have we, in our modern convenience, lost a bit of that monumental, awe-inspiring connection to the sky above us? Jai Singh II built an entire city of stone just to read the stars. It's a pretty fascinating reminder to look up every once in a while. Thank you so much for joining me on this